Hello, this is Kathy Go, and I am here to talk to you about infection, inflammation, and tissue healing. Now, this is a really broad topic, and I think what I would like to do is break it into three separate videos. The first video will deal with objectives 1 through 4, and that has to do with infection, lines of defense. The second video will deal with objectives 5 through 8, which has to do with the different constituents of the inflammatory response. And then video number 3 will kind of be everything else. Objectives 9 through 17, talking about the difference between local and systemic infection, acute versus chronic, regeneration and repair, wound healing terms, and various tissue wound healing and bone healing topics. So let's dive into part 1, which is the sort of some general discussion about infection versus inflammation. So you'll notice that in these objectives, I've kind of paraphrased the actual objective just so it would fit on the slide. So let's talk about the difference between inflammation and infection. So, with most infections, there's always inflammation, but you don't always have to have inflammation to have an infection. So inflammation is a broader response than the infection response. People use these terms synonymously, but they're not the same. So an inflammation is a protective response at the site of an injury. It can be caused by an infection, trauma, or other stresses. An infection is a pathological process caused by a microorganism that is transmissible from one host to another. So when you have an infection, you get inflammation, but not the other way around. So an infection can be defined as when a pathogen invades tissues, and inflammation can be caused by is a response that is immediate and nonspecific and results in redness, heat, swelling, and sometimes loss of function. But it can be caused by things besides a bacteria or a virus or other pathogen. So here we are, the definitions. Inflammation is a key part of the innate immune response. It's immediate, nonspecific, and responds to cell injury. So what happens in this response is that it neutralizes and dilutes the inflammatory agents by causing swelling, removes necrotic materials, establishes an environment suitable for healing and repair. So the goal is to stop the injury, limit the spread, and prepare for healing. That's key. Inflammation is not a synonym for infection. So let's talk a little bit about the chain of infection. So this is a foundational concept in nursing. And you probably remember Ignatius Semmelweis and the importance of hand washing. Well, this is kind of what that's all founded on. So let's talk terms here. Epidemiology is the branch of medicine that deals with the incidence, distribution, and possible control of diseases and other factors relating to health. Infection is a pathological process caused by a microorganism or pathogen that is transmissible from one host to another. Inflammation is a protective response at the site of injury and can be caused by infection, trauma, or other stresses. Pathogens, diseases causing a disease-causing organism. The host is the organism on which a commensal or parasitic organism lives. And virulence is the potential of a pathogen to cause disease in the host. Oh, forgot the T on that. So this is the chain of infection. As I say, this is a foundational concept in infection control. You'll see a lot of you'll see how this is lived out in the acute care setting where they really try to break the chain. So that is the key concept here. So you can see all the points at which the healthcare industry can interrupt the chain. So for example, the links of the chain include the in order for an infection to occur, all these links have to be connected. So there needs to be an infectious agent, a source, a way that the infection gets out of the source, which is the exit, portal of exit, a means of transmission. There needs to be an portal of entry to the host, and then there needs to be a susceptible host. So the way you can break the chain is you can identify the pathogen. You can be sure that there aren't good places for the pathogen to multiply, like making sure that there's sanitation and that objects are disinfected. You want to protect against the exit by hand washing and control of aerosols and splatter. That's where personal protective equipment comes in, like masks, stuff like that. You want to control the means of transmission through isolation, disinfection, and hand washing. And so there in that link, it talks about the different types of forms of isolation, which you'll learn more about. And then the portal of entry, ways to break that link are through first aid, like a Band-Aid, washing a wound, personal hygiene, and hand washing. So portals of entry are ways that the first lines of defense are broken. And then finally, the susceptible host. And you can break that link by having immunizations and treatments of underlying diseases, making sure that the host is well rested and all their defenses are in working order. So that's kind of the big picture. So here are there's a whole branch of nursing called infection control nursing, and it deals with these very topics. So let's look at this. So what you can do, so the link in the chain, first there's the reservoir or the source. So there are things that could be done like destroying the pathogens like mosquito eradication and sanitation. The portal of exit, you can block it by masking, gloving, isolation, and condoms are another example of this. Transmission, again, a blocking move. Sterile technique, hand washing, asepsis, cooking, and isolation. So cooking things kill bugs. Entry to the host, portal of entry, again, a blocking maneuver through masking, gloving, condoms. And then finally, boosting the host, reducing the risk by vaccinating, making sure that the host's immune system is in working order. So here's a great example of how you can put this into practice. When you do your Head Start activity, you know, those little kids are a reservoir for all sorts of viral infections, colds and such. So using your blocking maneuvers like washing your hands and making sure that you clean objects before you touch them, that is going to be super key so that you don't wind up getting sick there. All right, so let's go on to objective number 3, differentiate between first, second, and third lines of immunity. Now that rap video that I put on your ticket to class does a pretty good job of outlining these, and it's kind of fun too. So the lines of defense include surface barriers and internal defenses. That you can broadly break the lines of defense into 2 categories, innate and adaptive. So within the innate, which is what you're born with, there are surface barriers like your skin, and there are internal defenses like the inflammatory response. Then the another line of defense is the adaptive immune system, and that is specific, and its onset is delayed, and there's 2 subcategories of that: the humoral immune response, which involves B cells, and the cellular immune response, which involves T cells. Now, we're not really going to talk about that today, but it's out there and it's good to know about. So let's look at those lines of defense. In the innate defense category, the components are skin, for the first line of defense, skin and mucosa. And then for the second or internal line of defense, there are cells and chemicals. So how does the skin and mucosa, how do they protect you against infection? Well, there's a protective barrier. The skin has an acid mantle, so does your GI lining. There's enzymes in your GI lining and in mucus and in urine, and tears are acidic, and tears also contain enzymes. So those are all different types of mechanisms. And also the fact that it goes out, so it's pushing things out, it's not bringing things in. So when you're urinating, you're flushing your bladder. When you're crying, you're flushing your eyes and nose. So those are also some just physiologic mechanisms. And then the characteristics of the innate defense systems are that they are non-specific and immediate. So on the internal level, there's cells and chemicals. And that's characterized by the inflammatory response. And again, it's non-specific and immediate. So you get a cut, your inflammatory response kicks in, you get burned, same thing, you get a viral infection, same thing. So it happens irrespective of the stimulus. So then the adaptive defenses include antigens, which is part of the humoral response. And antigens, you know, that's where the antibodies hook onto those. That's how the immune response knows what to attack. It's delayed and it's specific. Lymphocytes are another part of the adaptive defense. Now they play a dual role because they participate in both the innate and adaptive responses. And they play a role in the cellular response to infection. And antigen presenting cells are another part of the cellular response to infection. And so those are pretty interesting because they're the cells that put the antigens out there so that the antibodies can find them. It's pretty elaborate, very intricate. And again, we're not going to clutter our minds with all this adaptive defense. You just need to know that it's out there. So let's circle back to the first line defenses. That includes the skin and the mucous membranes broadly. So within the skin, there's the epidermis, the acid mantle, and then there's keratin. So the barrier, the ways the epidermis is a barrier, acid mantle works in sweat, sebum, and it makes and urine, and the GI tract, makes a hostile environment for bacteria. And keratin resists acids, alkalis, and bacterial enzymes. That's in the skin. So the mucous membranes, you know, that's the internal lining of your body. Mucus, those cells that are part of the mucus lining secrete mucus, which traps pathogens. Nasal hairs filter and trap pathogens. Cilia propel debris and pathogens by mucus in the respiratory tract. And gastric juices contain acid and enzymes, and they're secreted in the mucus lining of the gut, or the cells of the gut. And then within the vagina, there's an acid mantle, which inhibits bacteria and fungi. Tears lubricate, clean, and they also contain some enzymes. And saliva contains lysosomes, also performs a lubricating function and a cleansing function. And urine has an acid content and a flushing action. So those are the first line defenses of your body. Pretty sophisticated, huh? The second line is the internal innate defenses. So this has been described as a symphony of responses to an attack. I just love that idea. So the players in this second line defense are phagocytes, natural killer cells, proteins. These would be plasma proteins. Fever plays a role. Pyrogens would be included in that. And inflammatory response in general, which includes pain, redness, heat, swellings, and sometimes loss of function. So let's talk a little bit about the third line of defense, which is adaptive immunity. Just generally, just so you know that it's out there. So the characteristics include, so there's two main players in the adaptive immune response. There's B cells and T cells. So the B cells are responsible for the humoral immunity, and it works through antibodies and cytokines. B cells also have memory cells, which can respond when they, on a repeat infection, and they're called memory B cells. There are killer cells within the humoral response, and those are plasma B cells. They're the antibody factories. And they protect against bacteria, viruses, and they work in the respiratory and GI tracts as well. So an example of a really extreme humoral response is a bacterial sepsis. So then we have T cells, which are is a cell-mediated response. And they work through, the cell-mediated response works through sensitized T cells and cytokines. The holders of memory in the cell-mediated response are memory T cells. The killer cells are cytotoxic T cells. The way they protect against fungi, viruses, so they kind of work on things that are attacking within the cell, chronic infections, and tumor cells. So an example of a cell-mediated response would be tuberculosis. So just know that this is a subject of active research, and new stuff is coming out all the time. So, what I say today might be modified by research that appears in the journals tomorrow. So within the innate defense system, there are phagocytes. So how they work is that a pathogen invades, it's recognized by pattern recognition receptors. So they go, oh, this is something that doesn't belong here. I don't know what it is exactly, which then triggers neutrophils, natural killer cells, and macrophages to respond. So the neutrophils are the first responders to any inflammatory at a site of injury or insult. So let's look at sort of a concept map view of the innate defense system. So there's two kinds of responses. There's, as you see here, there's the vascular response and the cellular response. So you get an injury, you can have a vascular response, which involves pro-inflammatory chemicals that are released, and you get brief vasoconstriction, then vasodilation, which results in redness and heat, increased permeability, which causes swelling and clotting, and chemotaxis, which attracts leukocytes to the area. And then there's the cellular response, which results in the migration of leukocytes. Chemotaxis is kind of like a tractor beam. It pulls those white cells to the site of injury. So the mechanism for migration of leukocytes include margination, which means the leukocytes go to the edge of the blood vessel wall. Then they kind of stick a foot through and climb through those tight junctions that we learned about last week. That's called diapedesis. And then they clean and remove debris and also attack pathogens. And then ultimately, there's tissue healing. Both of these responses lead to tissue healing. They lay down the elements that are needed for that. So that's sort of the big picture of this whole lecture. So in summary, the inflammatory response has four main phases. The vascular response, which begins with brief vasoconstriction, then vasodilation. the cellular response, which includes margination, diapedesis, and chemotaxis, and the formation of exudate and healing. So I would like to point out that there is some overlap between these two. They're not totally separated, as that analogy about the symphony implies. Each section, plays a part, but they blend together to form a whole. And that is the way the body works in general. You'll see that in every organ system. So let's talk about so this is the conclusion of the part 1 of this lecture. Thank you very much for listening.